do that to my video. Bear with me a couple minutes here while we get things going, hopefully. No idea if that's working or not. And I've got no idea. I think I'm supposed to log into Facebook here. Okay, let me do that again. And oops. But do that to my video. Where is that coming from? Bear with me a couple minutes here while we get things going. Hopefully. No idea where that sound's coming from. Oh, there we go. No idea if that's working or not. And I've got no idea. I think I was there. Got rid of it. Just a minute here. I just got one other thing I think I have to do. What is that doing? Okay, I have to have a new stream or something here because it's not the correct picture. Okay. New key. Streamed. Have to rename it. Hello. Oh. Manage video. I don't know. New key. That's what we'll do. All right, hopefully we're good to go there, I guess, and just have to get the audio hooked up here so I can hear and see, taste and feel. Now I gotta refix my focus once again. Somehow it does not keep its settings. Bear with me another minute. Okay, now I can broadcast. Bring in the people if there's anybody. There is not, but we're recording apparently. And let me check the live stream. Not good. Well, I don't know what's going on. I'm just going to bear with it and let it be. And if it's not recording in certain places, then people can let me know and I'll laugh because I won't be able to do much about it.
Yeah, Rick, if the recording isn't working on live stream, can you just upload the recording later on from the Zoom or something?
Yeah, that's right. That's what I usually do. So hopefully it's clunking along there, but there's some kind of serious lag happening with the live stream. I have no idea why. And I don't know if it's local issue or live stream issue or because I'm trying to stream in 4 different places at once or because I'm totally fractured trying to get my workshop going here a half hour late. I don't know. For whatever reason, it's all the way it is, and we're just going to go forward with it and try to bear with it all. Okay, well, let's start. half hour late, but anyway, doesn't matter. It's all good. This is the Keshe Plasma Reactor Group for Tuesday or Wednesday, June 26th or June 27th, 2018. I say that because there's only an hour and a half left in this time zone before it's Wednesday. But I'd be lying if I said it was actually Wednesday from this time zone. So in order to be honest and truthful, I have to say, if you're listening, it could be the 26th, could be the 27th. On the other hand, if you're listening to a recording a few days later, it could be any date. So time and dates don't really matter. And when we're in space, who knows what one day will be. One day be one of our months. Who knows? Okay, welcome today, and let's see what any of our panelists might have in store for us today. See, we have Lawrence and Peter and Jay, for example. They may have something to offer. And who knows who might. Oh, we have a bunch of attendees I have to invite in. I somehow have to find the magic button that says that to allow everybody to come in as panelists rather than this ridiculous thing where I have to promote each one at a time. I'll find the magic button one of these weeks, I'm sure. And bear with me for another minute while I find where that stupid chime is, because it's driving me crazy. Under one of the more buttons, not that one, and it must be on the other one. Where is it? Oh, that one. Under this one. Your preferences, maybe. Oh, Lord goodness. Completely lost, guys. Do you know how to turn off the chime and just have to let it chime when people come in? I just reviewed that 1 hour instruction video too, but I don't have a clue. I cannot find it here. Anyway, bear with all the glitches today as we go along. All right, let's get into it here. Anybody have something they want to present for today's show? Or speak about? Peter has mentioned that Vancouver Island, where I reside, has had over 4,000 tremors in the last week's time. Yeah, that's actually kind of normal for this time of year, when you're actually not this time of year, but I think it's every 18 months or every 16 months. There's a whole bunch of tremors that occur in Vancouver Island, and there's a little shift that occurs, a quarter of an inch or something like that, when the plates make a major shift. And this usually is an indication of that major shift. It may be the end of the world, on the other hand, but still standing. I plan to be the last man standing if that happens. I might be standing up to my neck in water, but I'm determined to keep standing. Okay, I'm told the Zoom is fine. Livestream is still laggy. Yes, I expect it will be. It's got the anti-lag feature triggered, so it tells me. No idea why, and I've already tried restarting a couple of times. It's unhappy, and I cannot help that. Okay, no one has anything to present today or anything they'd like to speak about, talk about, no topics, No questions. Pretty boring life, I guess. Eh? Nothing happening plasmatically in your life. Where have I failed? I'm supposed to inspire people about the plasma here. Guess I'm not doing too well. I don't get any responses. Questions on live stream? Nope. Any questions on YouTube? I'm not sure. It's too hard to tell. And let's check out the other one here. Hello. All right. Well, let's just sit with some dead air time for a while. And everyone can meditate on whether it's worthwhile to be here today.
Have you anything to show, Rick?
Not really, no. I had a busy day and I'm exhausted and I didn't get together my experiments. They're partially completed and a bunch of partial things, but been too involved with stuff and not able to complete things, unfortunately.
Do you remember
yes, I'm not a good role example today. Go ahead.
And I was going to say in last week's show, you were doing a thing with the Coca-Cola bottle, but the Coca-Cola was still inside it. And I was wondering if you'd found anything that, or what were you going to use? What was the Coca-Cola still in the bottle for? So is there some sort of fields come off the actual Coca-Cola itself?
Well, when you think about it, what was the magic, what do you call it? The magic formula that Mr. Keshe had in his cola bottle experiment.
I remember saying that, but I thought it was just because of the plastic and there's some chemical in the neck of the bottle. I didn't actually think it was connected to the Coke itself.
Yes, well, he did. I mean, it was a dark fluid, right? It was a black fluid, not a clear fluid like it would be if it was just caustic, or if it was the ganses, or none of the fluid in our CO2 kits turns black inside normally, right? Except for maybe if you're making carbon with carbon sticks, you can get a black kind of stuff that goes to the bottom, but even that doesn't really mix up in the water so much and so on. So think about it, what's in Coca-Cola that might be important in a reactor? Let's look at
the CO2 maybe. Carbon dioxide. I've never actually seen the Coca-Cola bottle experiment explained really in detail. I've seen them holding it and different things like that, but nobody's really ever went into how it all works and what it's about,
Well, there's many videos actually on it that Mr. Keshe has done in the original videos, and there's also in the patent it mentions and shows several things. Let me show a couple things here. Let's see here. Let me get lined up.
Hello, Rick. Good morning.
Hi, Lawrence.
Would you allow me to chime in?
Pardon me?
Would you allow me to chime in?
Is it about the Coca-Cola bottle experiment?
Yeah. I wanted to talk about the salinity things Mr. Keshe explained in the few teachings.
Salinity?
I think if you want to look at the chloralkali process,
well, wait a minute. Before we get into all these details, I want to show people what the cola bottle experiment is, and I want to
perfect.
get into that a little bit before you get into all these high-tech details about it that aren't part of the original patent, so far as I know. Let's look at the patent. Let's look at the pictures here. This is the actual cola bottle and some experiments being done with the checking the voltage at the electrodes. I'm not sure if that's AC or DC that is being checked there. Let me show a couple more pictures here. Here's this one that's quite bizarre. These are kind of pixelated because they were small pictures to begin with, but you get the idea. I'll just have a quick look here. A bunch of copper wires that are nano-coating themselves inside of this cola bottle reactor, basically. And there's another picture of that occurring. It's kind of a cool picture showing the inside of the, I guess this is from the mouth of the cola bottle looking in. And we see the different types of wire from single strand right through to fine multi-strand wires are being nano-coated inside the reactor. The point was that the nano-coating travels through the insulation of the wire right to the outside, back to the outside. I'm not sure if you got that last share, actually. Here, sorry, I don't think I shared that properly in the last one. This is the view from the mouth of the reactor of the cola bottle, showing all the different wires inside. And like I was mentioning, let me share it differently from desktop. And like I was saying earlier, the wires that go to the outside actually get nano-coated as well from the interaction on the inside. So that's interesting. So there's a PDF that's from the actual patent. You can have a look at that. This is on the USB, so-called USB stick that was given to governments as well as people from the patent application, the Keshe patent application. And we can see here the cola bottle idea on the upper left with a lower cola bottle reactor and an upper cola bottle reactor that appears to be collecting the gases that are, or plasma, let's say, that's emitted from the lower reactor. Now we see a bunch of squiggly lines coming out of that lower reactor in kind of the middle of it there, one of those electrodes. And that to me must indicate a radioactive source. Okay, so in this reactor, it uses, if we look down at figure 30, which I believe is associated with figure 28, this is the same reactor basically. It shows the radioactive source, and it shows potassium, K, which gets transformed from the radioactive source into K40, which is also one of the natural isotopes of potassium. And it has a beta decay, which turns that potassium into argon. And either both ways it yields to, well, there's two ways that happen apparently. The argon can be affected by the radioactive source and then scintillate, or it can decay from the potassium and scintillate and ends up giving off the EUV rays, the extreme ultraviolet. The extreme ultraviolet can work with the hydrogen to provide a ionization of the hydrogen into an electron and the H plus, the proton. And also, when that occurs, there's a photon given off by the electron that ends up interacting with the argon to again provide for scintillation, which the scintillation interacts with the hydrogen as well. And you end up with a circle of energy transfer. And you can end up with a net increase, more or less, of the energy due to that radioactive source, which is able to initiate or be the ignition or trigger for the process to occur. And he shows another different way of doing things in this other reactor here, using, they see there's iron and carbon involved in that one, which is not shown in the first reactor. But I want to get back to this idea of the K, the potassium. Well, it seems to me that would be one of the things that would be pretty high in the Keshe fluid if it included the Coca-Cola, which is high in, I believe, both potassium and phosphorus as well, if I recall. And also the Coca-Cola fluid is basically sugar, which is carbon and hydrogen. So you have that CH that's available to you. And so instead of using the necks of the cola bottles ground up, which is also a source of the CH bond, carbon, and a source of the hydrogen through that carbon-hydrogen bond. And if you can separate the carbon, then you've got the hydrogen already liberated as part of your formula down here inside the reactor. So I believe that the bottom line is, I believe the cola water is part of the necessary ingredients to initiate or make the creation of new materials or creation of energy more accessible, creates the right environment that gives all of the materials ready there, ready, available to go, as well as cola is very acidic, and so it can add to the it can perhaps balance the caustic in a way. And if you balance caustic with acid, then usually you produce a salt, and that might be a good way to introduce Lawrence's idea of salt, perhaps.
Yeah, I've been thinking about along the same lines. I think the darkish liquid is not the Coca-Cola liquid that the company produces and that we drink as soft drink, but it's, I think, some form of H. I think H2. If I remember correctly, we had the H3, which was the orangish color, and then the H2 turned blackish or darkish, greenish something. So I think Mr. Keshe was creating the conditions for the H3, H2, H1, and then the creation of the neutron plasma in the Coca-Cola reactor bottle. And the thing he was hinting at was maybe mixing some table salt, sodium chloride, into the mixture. Last teaching, he said, if we keep the alkalinity up, if it doesn't turn acidic, we are still working in a plasmatic environment. And the thing I wanted to point to was the chloralkali process, because we've been talking about something like this about a month ago or 2 months ago, how the NaOH is created. And it's created on in an industrial scale in the process where table salt is transferred through an electrolytic process.
Electrolytic process, exactly, yes. And it's quite simple, but I'm surprised.
It's very simple, and as a byproduct, hydrogen is created. And if we mix the NaOH liquid with NaCl liquid, we will have, due to the energy release of the NaOH dissociation, the same thing happening to the sodium chloride solution. So we will be creating H2 at least on a chemical level if we look at it. But if we keep the alkalinity high, then we are still in the plasmatic environment. So all the processes that we are working with on the plasmatic level are also happening. So I think the Coca-Cola bottle needs a little potassium, just like you showed for the beta radiation, and also some sodium chloride, a small amount, to create hydrogen gas. And if the hydrogen is created in this plasmatic environment and through the gradient difference of the different liquids and the liquids and the air that we have, and some of the electrodes are put into the liquid, some are in the gaseous part of the bottle, we will be creating conditions to, if we're doing it right, so that the liquid is getting filled up with H2, and this is how it's getting dark. It's basically the guns of hydrogen gas, the H2, that turns the liquid dark. So basically we're creating a nano coating and a GANS capture kit all in one, creating the conditions for the H2 and then capturing it in the liquid. And then that H2 creates different conditions around the electrodes. Basically, the nano is then being fed by the GANSes that are around in gaseous condition. You understand? And this is what he's measuring with the electrode probes, how big the plasmatic gradient difference between the electrodes is.
I think I understood at least part of that, most of that. You'd have to. There was actually people that we had the formula for the was it KT fluid, I believe it was called at one point. And maybe somebody has more info on that we can try to discriminate exactly what that was. There was, I think, there's definitely potassium in it as far as, or was it, I believe there's potassium in it as potassium salt, or it might have been KOH. I believe it was KOH actually was part of it. So NaOH, KOH. And I believe a bit of sugar water, enough to color it. And the ground up caps from cola bottles. Not caps, but necks rather. That was part of the essential formula. I'm not sure what all the chunks we see in the liquid here in that upper cola bottle are. There's different shit. There's five-sided shaped things and star-shaped things and small little things, and I'm not sure what that's to indicate. If it's I'm not clear what that means. there's probably a, there might be a directory to those somewhere here, but I haven't got that handy. So yeah, we're not completely clear on the liquid, but I think you're in the right ballpark there, Lawrence, about I mean, there's lots of ways to generate hydrogen in a bottle like that. That's not an issue. You can put in a tiny bit of aluminum foil in with some caustic, and you're generating gobs of hydrogen, way more than you would normally need. So that's easy enough to generate hydrogen as far as that goes. But what you're talking about, I think, is the special hydrogen, and preferably actually the atomic hydrogen, which is important to the process that we see that goes on in this closed reactor loop in figure 30 here. It's actually, if we look at that, what we see is hydrogen in this could very well be, instead of hydrogen, it could be H2 or H3. Even speaking naturally in terms of the physicality, atoms, the actual element hydrogen, each time there's a plain hydrogen, atomic hydrogen generated through this process or gets affected by this process, one out of, what is it, every 2,500 atoms, I think, is an H2, a deuterium atom. And one out of every million or two is an H3 tritium atom. So when this process occurs to them, they get a separation into the hydrogen plus a neutron or two neutrons, basically. So it could end up with neutrons as part of the process, rather than just the protons and electrons being separated as shown here. So it becomes more interesting once you introduce the idea of a neutron being involved in that whole process. Let's see, anything else you wanted to say about that, Lawrence? Any insights? And Jay wanted to know what scintillation is. Well, let's properly look it up in Wikipedia, and we can have a look at what the see what the official word on it is, and that'll give us a basis to look at. We've done this before a couple times. So if we look at scintillation in physics, is a flash of light produced in a transparent material by the passage of a particle, which could be an electron, an alpha particle, an ion, or a high energy photon. Okay, it's a process of luminescence. Okay, so this is emitting light, basically, is what we're talking about. And this can happen, it mentions it's emitted following the absorption of radiation. So what can happen is, if we look back at our diagram here, the radiation that comes from the beta decay of the potassium-40 produces scintillation in the argon, which ends up lighting it up. It creates luminescence. That's the same sort of thing you see in a plasma ball when the plasma ball is lit up. It's basically a scintillation process, or it's the photons we see from the electron when it drops down a level and so on, or goes back and attaches to the argon after it's ionized. So it's a says scintillation occurs in okay, also it mentions the emitted radiation is usually less energetic than what is absorbed. So for example, with this scintillation of the argon here, it emits the EUV rays when it scintillates, and that's what's useful for converting the hydrogen, ionizing the hydrogen. So it's like a multi-step, step-down transformer kind of process that occurs to get to the point of separating the proton and electron and being able to manipulate them to give you the hydrogens that you need to work with in a reactor kind of setting. So it also mentions that scintillation is occurs in many inorganic materials, including salts, gases, and liquids. So it's interesting they mention salts there. And it gets into a bunch of formulas and ideas behind it. So basically it's a luminescence that occurs. But if you look at the Keshe patent, then it's all part of the process as shown in this diagram, which basically is the process that occurs in the rotating reactors of the Keshe patent as well. It's the scintillation ends up giving off rays which are useful to another process within the reactor. And that process wouldn't take place properly without that scintillation, which acts as essentially a transformer. Like, for example, in this diagram, you wouldn't want the radioactive source activating the hydrogen directly because that won't work properly. It doesn't have the right field strength to activate it to ionize it. So it has to go and hits the argon first, and it scintillates, and its rays give off the rays which are able to activate the hydrogen and prepare that for further use within the reactor, possibly resulting in fusion type processes or other transmutation of elements, giving off energy, creating fields from the hydrogen plasma so that you can operate gravitational effects and that sort of things, depending on the gradient of what you're working with. Maybe this cola bottle isn't enough to create gravitational effects, but maybe if you do like I wanted to and rotate the reactor under certain conditions, maybe it would be enough to create the effects. Okay.
Rick, do you see in the diagram beside the bottle, is that just the same idea only with wire and resistors?
Yeah, that's the way I understand it. I haven't looked into the full aspect of this, but basically it's very similar to the plasma batteries and plasma capacitor kind of setups that we tend to use. But in this case, there is, I'm not sure if figure 29, I think figure 31, I think is associated with figure 30. I think it's Figure 29, I think, is a different setup, but perhaps it's there to describe the same phenomenon. It's perhaps a bit hard to say. I haven't really looked into that one too much. I don't think it's associated with the closed reactor diagram, figure 31. I think figure 31 just shows a different process, perhaps with different materials. We have the CO2, or maybe it's in the same reactor, it's just a different process that occurs. Because the first figure 30 shows the process of achieving the monoatomic hydrogen that's talked about, which goes into the top reactor. That's the little dusty particle kind of stuff that you see in the top cola bottle reactor. And then if you look at figure 31, this is actually the process occurring on the electrodes, as far as I can tell, on the actual electrodes inside the first cola bottle, and the process inside of the CO2 leading to the graphene carbon coating on the electrodes as part of this process. And there is also, of course, the copper, nano copper coating as well that occurs at the same time. So we have several different processes going on inside this relatively simple little reactor. So it actually demonstrates many processes that occur in the universe. And this is the whole idea of what Mr. Keshe was trying to show with it. And in one of the videos, you can see it looks like a mini universe inside. They've interplayed the picture of the universe inside, and that's just to show that this little cola bottle is like a miniature universe inside. That's my wish, to create conditions inside a cola bottle similar to the way things work in the universe as well. Especially when we have rotative, compressive, turbulent, heat, and other processes that can all be, see where my window go here.
Well, the bubbling of the NaOH is definitely a turbulent and heat-inducing environment.
Yes, although it needs to be, sorry, I'm just trying to get my video pinned here and I'm having trouble with, okay, I think I just have to stop share in order to do that. There we go. And yeah, so I just wanted to show, so in something like this, an ordinary cola bottle, other than it's got this weird fitting glued on the bottom. So now it's a screw fitting that can screw into the fitting on my lathe to be able to rotate it, or into my other apparatus that can rotate at higher speeds. And now I've got an electrode in this end, although I'm also, for another iteration, it'll have this hollow tube, brass tube, going inside the reactor to be able to access the core of the reactor through the hollow tube while it's rotating. And then yet another iteration with a similar idea. It'll have a cap with the Septa Seal. It's called the Septa Seal, which is a little seal that's able to have a needle go through the seal without disturbing the vacuum or pressure inside of a vessel. So I can remove or insert a bubble or GANs or nano or caustic or hydrogen or whatever I want to put in there, take out of the reactor with a needle. And once the needle's withdrawn, there won't be any leaks of gas or liquid through the Septa Seal. So I just have to glue that on this cap. And the little Septa Seal will enable that to happen. And so what I can have, it's great with this bottle arrangement, is you can have a series of caps for different jobs, let's say. So one of them might be a hollow tube. And one of them might be a this little Septa Seal that I mentioned. Another one might be a high voltage electrode or other type of electrode. Can also put zinc or the copper oxide, the copper nano coil that would have be able to just screw in with the cap. The coil would be perfect. Don't have a good example here, but you can imagine just a little coil dangling off of here, black coil, and you just simply screw it into the cola bottle. You would need some support to be able to take a rotation. That's okay, that can be worked out. So lots of versatility with this. And right now I've got this filled with argon gas. I've got a canister of argon. I was able just to fill it with argon. It's very easy to do. So it's a starting point. It's also very easy to put hydrogen into such a environment, not to mention other liquids or gases or other layers that might like to put in to provide the walls of the reactor, you might say. So it's actually a pretty exciting way to interact. And once the layers are set up inside a rotating reactor, then there's a possibility of the fields building up in sort of like a capacitor kind of way.
Yeah, I would say you're on the right track, but you should think in terms of fields rotating, not the actual matter rotating. If we create a layering by means of the gases or the liquids, this is why I said we should consider the table salt as an ingredient too, because if we have NaOH and NaCl and they separate, we get the chloric acid, the acidic liquid, and the NaOH liquid, which is the alkaline liquid. They themselves, if we have more alkaline than acidic, will still be in the plasmatic environment and create a gradient within each other so that they start feeding within the liquid. Then we have the next layer, the gases. If we put the potassium in it, we will have the beta radiation source that then creates out of the potassium the argon, so that you don't have to fill in external argon, but you create it out of the nuclear process.
Yes, and right. The ideal.
And the argon will be in the gaseous environment on the top of the liquid. And the radiation source, that grayish thing on the picture, is, I think, simply the nano-coated gravitational copper that's coiled and then in the pin format, also connecting the outer of the bottle with the inside of the bottle.
Well, I buy the rest of your theory, but I don't go with the last part.
Okay, it's cool.
I'll buy the rest though. How much?
and the whole point of this whole setup is, I guess, to feed the nano with the ganses in the upper part of the reactor. It's the same as we have with the MagRev setup, where we put the ganses with bathing the MagRev coils in the GaNs liquid or in the GaNs paste. We do the same thing here in the Coca-Cola bottle, just by creating the environment of the ganses around the nano-coated copper. And if we have the right salinity ratios of the NaOH, the NaCl, and the KOH, we will have the creation of the same thing as Mr. Keshe explained with the H3, H2, H1, that we have the neutron in the center, the free plasma, the plasmatic neutron that is the mother of creation. And that is the huge energy source that if we have the right distance of the nano-coated wires or the probe that we put into, we can tap into. And
yes, right, exactly. That's a good point.
And if you remember last time, he also explained if we put three H3 reactors next to each other, they start feeding themselves, and two of those will start changing color without any rotation or anything, just through the movement of the fields. And we have the same setup inside this Coca-Cola bottle reactor because it's a plasmatic environment. We know that will be creating H2, hydrogen. I think in a chemical process, we also create the brown gas, which is the basis for these water-fueled cars or whatever.
HOH.
Yes, something like this. But the whole point is to create the plasmatic neutron to have the mother of creation available for energy and for anything. And it's this salinity secret and the movement of the fields that the different gradients. If we take a look just by the different gases that we have in the upper layer and the liquids that we have in the bottom layer, we have many plasmatic gradients that feed each other from top
we also
to
have
bottom and from bottom to top.
Gravitational gradients in terms of the weight or the apparent weight due to gravity of those substances, let's say. So like the fields will be created by the gradient, but in order to get that gradient, one of them will need to be heavier than the other, the acidic versus the alkaline.
Yes.
So whichever one ends up being the heaviest will be on the outer skin of this rotating reactor.
If you don't rotate it, it's just sitting there. It will just gravitate to the bottom. The heavier things will go to the bottom. The lighter things will go to the top. This is why you have the second.
Well, a lot of times there'll be just a mixing. Like normally, if you mix, I don't know, sugar water with water, it doesn't. Sometimes it'll settle on the bottom as sugar water. Sometimes it'll mix in with the water, depending. So we would have to find the way to, if it normally separates out according to gravity, if you were to pour two different liquids in here, an alkaline, acidic, and assuming they didn't immediately mix together and neutralize each other, which is mostly the case if it was, for example, vinegar and baking soda is the classic example. When you mix them together, they don't stay separated. They mix immediately and bubble up, and that's the end of the separation. But if we did have a way of separating due to density, let's say, call it density, then that effect in spinning would be even more so, even more profound. So instead of the effect of one gravity doing the separation, we could easily be under the effects of 100 G's force, 100 times the force of gravity, producing even more of a stretch of separation. The heavier ones really go to the bottom, the lighter ones really tend to go to the top. In this case, instead of there's no top, when it's spinning, the top is the very center. The lightest will gravitate to the very center, and the heaviest will be on the outside wall as this rotates, and the gradient will be from the outer to the inner in a series of steps, let's say, due to the different fields involved. That's kind of the idea.
You remember the different GANS boxes that had the yin and yang symbol in them? You know, where they separated. You had the middle line. You had the one at the one side, the other on the other side. I think it's that kind of slow and natural separation that's automatically created within the plasmatic environment, because this is why I said we are creating the conditions for the creation of the ganses, and then we're also capturing them. And this is why the liquid turned darkish, because if you create the H2 and then capture the H2, it's the H2 that's when it's in a plasmatic or GANS environment, and that it turns greenish, darkish. So the Coca-Cola liquid is basically the GANS of H2 that's been created through the interaction. And on the one side, you create the conditions for it to behave as a plasmatic, and on the other side, you capture it as GANS. It's a very fine balance. I don't know the exact ratios. We could consider it and calculate how much of the different salts we need to put in to create the exact effect. And the separation, this yin and yang in the same bottle, is an expression of a gradient, of a plasmatic gradient.
Yeah, good point. That's a really good point, actually. So the separation is so important. It's often Mr. Keshe seems to talk about, and others as well, of course, that if you look at the yin and yang thing, you've got the yin and the yang, like the two symbols you're talking about, they're intertwined and so on. But what we don't see is the neutral skin that's in between the two of them, because in a way you have to have that neutral force in between. There's always an interaction, like on our skin, we have the outer skin, we've got the inner skin, and we've got there's like an insulating part in between. That's what keeps the two gradients apart from each other and allows the transfer to occur of various processes that are going on. So it's that gradient that's important. The same as in high voltage, there's you can have what's called the dielectric discharge, which is basically a glow discharge, and you can have that in atmospheric pressure and conditions. Basically, it's works by dielectric. So you have an insulating layer, and you would have a conductor on top of that and a conductor underneath. And you put your voltage and potential onto that conductor underneath. And because of the insulator, it develops a potential through the insulator to that other electrode, and it can start to glow or do other things because it's receiving the potential without it sparking in between, essentially. So it's creating the gradient without discharging the gradient. So normally the gradient would be discharged. In the case of acids and bases, for example, with the vinegar and baking soda, you would have an extreme gradient between the two. Think of a fire extinguisher, the kind that you turn upside down in order to make it work. Those are kind of old-fashioned now, but the bigger ones, that's the way they used to be, at least, and probably still are. It's basically like baking soda and vinegar, and some of them actually use those as materials. You turn it upside down, the baking soda is in a little basket, it mixes with the vinegar. I had one of these as a demonstration thing when I was a kid. You put vinegar and baking soda in this little fire extinguisher looking thing, and you squirt it around the kitchen and get in trouble. But you turn it upside down, it's the pressure from the CO2 expanding pushes the liquid out and creates the CO2 gas as well, which combines to put out the fire. So, but it dissipates the potential. That potential is there for all this pressure and gas and so on to expand out and put out this fire and create all this work. You could hook it up to a turbine and actually get energy out of it if you wished. So all this potential energy sitting there, but as soon as those liquids, as soon as those materials combine, they basically neutralize each other, and you end up with a sort of water and some gas, CO2 gas given off. So it's important to keep that barrier in between in order to keep the potential. If you need to work with the potential, if the potential is what creates the fields, then it's important to keep that potential and not allow it to dissipate. The same as the idea of in the reactor to create the plasma, to not allow, once the plasma is created, to not allow the plasma to hit the walls of the reactor, because as soon as it does, it dissipates the plasma. Not to mention it could blow out the walls of the reactor in certain circumstances if you had a high energy plasma. But the idea is that you will never get high energy plasma if you don't have a container that allows that to build up without dissipating. So that's kind of the whole idea of the rotating reactor, the Keshe reactor, the globe that rotates. When it rotates, the gases inside, as I've demonstrated even with a plasma ball in the past, when it's rotated, the gases inside will form layers and will create certain effects between those layers. And as we were talking about the scintillation that occurs and the effects going backward are very important. And each layer of gas that Mr. Keshe has specified in the rotating gaseous reactor is there for a purpose, in order to either allow that scintillation process to occur, in which case the rays go back inward toward the center where the hydrogen is, and it allows the ignition of the hydrogen. And the other layers beyond the layer that's scintillating would add to the buffering effect, let's say, and not allow any high energy rays to escape, because it acts as a buffer and absorbs the rays and again scintillates down to the next layer, which can produce the ionization that we'd be looking for of the hydrogen. And that whole process of obtaining the bare naked proton, and not to mention neutron. So it seems like, if, speaking of which, if we had the bare naked protons and electrons forming inside this spinning reactor, then what if we had certain coils of wire? This is sort of a demonstration, but if this coil of wire was wrapped around this while it's not wrapped around it, but not touching it, but around it as it's rotating, let's say. And if you had a coil here and a coil over here, then you might be able to create, with the correct field combinations, with the magnetics and the coils and the plasmatics operating, you should be able to create a separation, call it positive and negative, or entry and exit to the fields in this reactor, which would allow that separation, that all the protons go this way, all the electrons go that way, and the neutrons can stay in the middle. Hey, that's pretty good. Protons, electrons, neutrons. I think I found the secret of the cross. Protons over there, electrons over there, neutrons in the middle. Hey, that looks really cool. Let's make it into an emblem that everybody will remember for thousands of years. That's a big one. Okay, so anyways.
Well, you're kidding, but in part...
partly kidding.
Nature does this separation on each level. It's even simple water, when it gets to a hydrophilic surface, creates nanostructures, hexagonal little towers, and pushes out protons. to the other side and creates this capacitor or the separation. It's the so-called fourth phase of water, as coined by Gerald Pollack. He's a water scientist. He's been giving lectures.
Is that part of the easy water?
Yes. Easy water is the other name, and it's the same structure as you've explained. And the fuel for it is radiant heat. It's heat. It's basically given off. It's the radiation. It's the light of the sun that's transformed into heat. A certain wavelength of the light, as we call it, heat, is the fuel for the creation of these nanostructures within the water. And then we're only talking about simple water without any other things added.
Well, the other thing that scientists have discovered recently is that water is actually self-ionizing, which is an amazing phenomenon if you think about it. What that means is if you're think of I don't know how to, I probably should do a whiteboard or something, but just think of a H2O, which is two hydrogens, then oxygen with a kind of a bend to the bonds. So if you think of it in the very simple terms of science and whatnot, of a simple hydrogen H2O molecule, I think it's 109 degree or 107 degree angle between the hydrogens attached to this oxygen, blah, blah, blah. So it turns out once every approximately 20 hours to 24 hours in that range, every water molecule undergoes a spontaneous ionization where one of those hydrogens will separate from the H2O, leaving OH minus and the H positive, basically, as the two ions involved. So it becomes a charged ion through ionization, self-ionization, and then within less than a picosecond, the hydrogen comes slamming back into the molecule, making it back into a water molecule again. This is why they never discovered the self-ionization of water, is it happens so quickly. They had no way of measuring it or seeing it before, but now they have microscopes that can see smaller and smaller, and they have the time frames of being able to record on faster and faster levels. Like if you only have a recording device that's 30 frames per second, or let's say 25 frames per second, well, that's every or let's say 10 frames per second to make it easy, then you only have 1/10 of a second between each frame. And if your picosecond happens, which is like, what is that, a billionth of a second, if that happens somewhere during that 1/10 of a second frame, that you wouldn't be able to capture it, because that frame only captures a little bit every 10th of a second, and it doesn't capture all those picoseconds that are happening during that 10th of a second. So they're getting better and better at recording stuff that goes on, and they discovered inadvertently that water is self-ionizing. And I think that's quite a miracle, and I think that we can take advantage of that. It makes sense to me that when water is busy self-ionizing once every 20 hours, why can't we, at that moment where it self-ionizes and separates itself, why can't we keep up that separation by having the fields already created? So when those charged parts become charged from the separation, they instantly get removed to positive guys over here, negative guys over there, and keep your separation. And through that separation, the gradual separation, just through a natural ionization of water, we should be able to keep the ions separated. And once they're separated, you have that amazing potential for creating some kind of electrical force. Basically, it's the that gradient that we've been talking about. And you would essentially be creating an acid and a base through that natural ionization of water, where it goes from the H, which is the acidic, and the OH, which is the alkaline. So it's interesting, anyways, how if you look at that in plasmatic terms, well, it just shows how dynamic something that we take as for granted, like water, can actually be. It's undergoing self-ionization. It's creating clusters of water they're discovering as well. Some of these clusters are quite large and some of them are quite small. And then in the case of like the easy water, then we have basically monoatomic or monomolecular chunks of water that don't have the big clusters that are so hard for our cells to break down in order to hydrate themselves. The cells in the cell wall can only absorb certain sized water clusters coming in. And if the water is heavily contaminated, you get big clusters. Big clusters are hard to break down. It's like a small plasma trying to absorb this big plasma that comes in. It can't handle it. It needs to come in smaller packages. And those smaller packages are what's called better water than polluted water, for example, or the ones that have been structured or gone through processes, or easy water, or other types of things to make it not just purified, but actually breaking down those larger clusters. And part of that is with the idea of using the CO2 GANS water mixed in with the water that we might drink, or if you wanted to purify the water for other purposes, you mix in the CO2 GANS water, as Mr. Keshe has described at one point. As the GANS filters down and settles down to the bottom of the container gradually over time, it acts as a filtering, more or less like a mesh sort of filtering process that breaks up the water to make it into a finer structure. Let's say, instead of bigger chunks, it breaks it up into finer. Only the finer clusters can make it through this sort of mesh of the CO2 as it forces its way down. It's kind of an interesting idea, and therefore taking any heavy things that might be in the water out of it as well. So, go ahead, sorry.
It's the space gap storage.
Yes, right.
Just as the water creates the nanostructures on different surfaces, this easy structure, when we shake it and let the GANs settle, we create clusters of water that have the information within themselves stored. It's like water is as a readily available medium for storing any kind of plasmatic information. It's in the metal level, it's easily accessible, but the structures that the molecules themselves can form, these clusters, have the plasmatic information stored, and it's always the plasmatic information with which the cells operate. It's never the material, the molecule itself. When we're talking about contaminated water, it's when the water is filled with matter. When it's filled with plasmatic information, it's full of life. This is go back to how we breathe, whether oxygen goes through our into the bloodstream, or how it's energized. Teaching about this thing, it's always the plasmatic information that's the engine of life.
Well, good point. Yes.
And when we have clusters of water that have or similar structure strength with each other, they form a different size of, say, crystal lattice, then when we would be considering, for example, the nano-coated copper. The nano-coated copper is a static thing. It's a structure as it's been created at the time of creation, and it stays the same. And with the water, we can charge it, then discharge it, and create new and new lattices with different kind of plasmatic information stored. This is why it's very important to have a good emotional state when working with the GANs creation or any plasmatic process, because we ourselves have a very strong field effect on the water and on how and what kind of things are created. So
it's true about water and fields. I mean, you can see that just on the physicality level, the way water interacts with electromagnetic fields, as an example. Whoops, I didn't have my live stream on there. It's just talking about how water interacts with fields is very true, and especially with electromagnetic fields. We've shown that here a number of times. And most of our bodies composed of water, so therefore our bodies interact with electromagnetic fields. Some people can hear radio stations in their fillings of their teeth through the processes of working with the water of the body, and the whole body acting as an antenna. When you touch an AM radio antenna, it tends to make the radio louder. That should indicate to you that we operate as pretty good antennas for just about any signal that comes through. And literally, when this plasma ball is operating, the fields are going through my body and being amplified by my body. And if I was to use a device to measure the fields, I would measure the fields on me as being stronger than the fields emitted from this device, just in the air. So, and the same with same as radio stations, the waves are, and I'm talking about just not like radio waves, but the standing waves that occur from this, because there's standing waves like in spherical kind of shells that come off of plasma ball, and as well as there's electromagnetic waves that go out and so on, different frequencies. But that's true of anything that in the universe that's generating fields and waves. The fields of the sun are not really noticed or recognized until there's something that gets in the way of them that actually absorbs the fields and transforms them down into something that can be observed or felt or seen or heard or whatever. Look at the earth and the way the fields interact with our atmosphere to transform and convert both the atmosphere and the fields as they come through. If it wasn't for the atmosphere and the magnetic fields that we have as a buffer on our planet, then basically we'd be fried by the cosmic rays and the interaction of the UV rays and so on that are detrimental to human health if we're in excess. So okay, what else about that? Just have a look at some of the chat here. Peter, you're mentioning to replicate the frequency of H3 and collect it using a multiphasic techniques and N-CFA. I'm not sure what N-CFA is. Theoretically, collect H3 or anything really, as long as you have the frequency, you can replicate anything. Well, depends what you mean by frequency, because frequency alone is not enough to replicate something. But if you have the frequency of a bird, can you replicate the bird? Not sure about that. But I know what you mean. There's interaction of fields of certain frequencies can end up creating certain stuff. So,
Hello?
hi, Lawrence. Yeah.
Yeah, well, you've been talking about frequencies. Do you want to go back to string theory, like Pythagoras and all these people, you know, the ratios, the octet?
Not really, because I mean, this has come up with Mr. Keshe in the education class and so on recently. Someone presented a video with a bunch of sacred geometry and all kinds of angles and measurements and stuff in it. And it's actually not really part of the teaching of the plasma so much. There might be certain relationships and so on that are important, but you don't see a lot of sacred geometry kind of things in the books of Mr. Keshe, for example. In fact, I think the only formula that I've seen in his books is E equals MC squared, and it was in reference not so much to the formulas so much as to probably how incorrect the formula was or how it should be corrected in the plasmatic way.
Well, the reason I brought this up is because the big spiral he's always drawing is basically one huge line. So if you draw one line, say consider that the magnetical, that we see the line that's drawn, and then we have the line turning back onto itself, that's the gravitational. So basically we have two lines. And if you can consider the one, are you there?
Yeah. Mm-hmm.
If you consider this these two lines, the magnetical and the gravitational, as one line again, then you basically have a string that is plugged at a certain distance. And then basically, if we're talking about this pulley game of the magnetical and the gravitational, it depends on where you plug the string. So basically, this whole universe is the magnetical and the gravitational as one huge string, and where you have something emanating or visible is the end of the string, but the magnetical turns into the gravitational. Can you imagine what I'm explaining?
Nope.
Okay.
Don't have a clue. I think we need a. Do you want to try a whiteboard explanation or some other visual, some other explanation that might spike visual?
I can try. I have the desktop here. I will try to.
I can make the whiteboard if you want, and that might help.
Okay, thank you very much. I noticed that I have a different kind of way of drawing than how it's been presented with the other people. That I mean, like when I draw, I don't see on the video recording the way my mouse moves, even though Mr. Keshe, when you were drawing, you always show your mouse. Maybe it's because I'm on a different client. I mean, like Linux, but.
Well, give it a go there.
I will try. So in the drawings, we always have the big spiral. And as you've seen, I'm drawing the spiral by not raising the pointer. And this spiral, say, is the magnetical from inside to the outside. And then from the outside, we have another, the space gap in between, that's the gravitational going in. It's again one line. So if you notice, what I've been doing is I've been drawing one line going out, that's the magnetical, and then one line going back, the gravitational. And we can also put these lines next to each other if I clear this screen, then I have one line, that's the magnetical, and then another line, that's the gravitational. It's again the same drawing that I've been drawing first with the spiral, where the magnetical is visible and the gravitational is not visible. And if we go in this direction, then we're basically back to what Pythagoras has been teaching about with the ratios, with sound theory. So basically, if I have one line and I put it and I cut it in half, then I still have 1 and 1 here, but I can go different ratios. And I'm always, it's this teaching of the subharmonics and the higher harmonics. If you have one sound, then the higher tones and the subtones of the same vibration will resonate with it. And if you go in a different ratio, then the different tones are resonating with it. So basically what I wanted to say is that just like as we with our voice and sound that we emit as humans create different kinds of frequencies, we express different emotions. And sometimes in the past, when we were very well understanding of this plasma technology, we were able, just like Mr. Keshe with Naomi, use different words to create different plasmatic effects. This whole magnetic and gravitational, the ratio of the two and the changing of the two is like when we use the two plates in the CO2 kit. We have one gravitational, the nano-coated copper. It's the ratio of 59. And then we put another matter to it. That's, say, for example, zinc. And then we create the connection with it to create a plasmatic effect. So sometime we will have to be able to, just like we use math now to calculate different things, create qualitative effects, plasmatic effects that create different conditions. And we will have to be able to think of it, just like we've been talking yesterday about the wishes. A wish is something that we've been actually forming as a picture. We can give it a name, we can tell it as a sentence. So we need to be able to have different mental tools with which we can operate to be able to, say, control the spaceship. It's just like, where do you want to go? It's not only, I love the whole universe, but I exactly know that I want to go to planet Zeus. So we have a mental tool with which we can operate to control the plasmatic effect that we want to achieve. And this whole sacred geometry thing that I've been bringing up is basically also the same understanding, the same pictures as we've been shown, and the explanation that we've been given have already been given to us at some times, but we forgot how to use them. So I think it's appropriate to start thinking about it again and to work with it. I think I can clear the screen, and thank you for listening to my little explanation.
Okay, thank you, Lawrence. Is there anybody with any questions or comments for Lawrence or otherwise? Okay.
Hello, Rick.
Shibani, how you doing?
Fine. Please, I want to ask a question.
Mm-hmm.
Last time when Mr. Keshe was talking about creating hydrogen tritium, am I correct? I understand that to produce material, you don't have to connect. My question is that the copper, nano-coated copper and zinc plate copper, which inside the box of CO2, if I put CH3, can I connect the nano-coated copper and zinc copper, or I don't connect it?
The way I understand it is they should be connected in the standard way for making a CO2 kit.
Yes.
Connect with an LED or nano-coated wire, perhaps?
Yes, that is my question. Because you say that producing material, if you connect, maybe you take CO2 box. If you connect and you put CH3 inside, maybe you will produce another material. I understand that to produce a H3, when you put nano-coated copper, zinc plate copper, just create the condition and take CH3 in the box, put inside CO2 box. The salt condition creates the condition of having H3. I want to know if you connect or not connect.
Let's review here. Who's doing the drawing? Sorry.
Okay.
That's you? Okay. So you've got your copper nano-coated.
Yes.
You have your zinc.
Yes.
And your CH3 is what, in a container, right, in the middle?
Yes. Yes.
Okay, right.
Okay. Yeah. You connect them or not?
The way I understand is you connect it like you would in a normal CO2 kit with a LED or nano-coated wire twisted together as the connection to make a partial resistive type connection there.
Okay.
They shouldn't be connected directly with a wire, but indirectly through an LED or a computer fan or something to dissipate.
Okay. Thank you, Mr.
And also you need not only zinc, but also chicken wire, zinc and iron for the
Yeah,
seed.
that's to create CH3. That's a whole different experiment. This is to get the, we're talking about to create the H3 GANs with this, to remove the carbon from the CH3, right? You're talking about creating the actual CH3 in the GANs kit, Lawrence? Is that what you mean?
Yes.
Right. So this is, once you've got your CH3 that's already created from that chicken wire process with the nano-coated copper and zinc, then you can, or without the zinc, it's just the chicken wire process, you can put your CH3 in a separate glass container in the center of another glass container CO2 kit, basically, and draw, the idea is to draw the, let's see, speaking of drawing, I can just have a pen here. You can draw the CH3 into the kit, draw the carbon into the kit, and leaving the H3 as remainder in your glass container, being the tritium GANs. That's the idea I understand by it, at least. So there's two different processes going on there, is the point. Anybody else have something to add to that, or better description or questions about it?
Hi, Rick, I'm done. Somebody else I try it only with balls full of GANs of, for example, copper and zinc for a kit of CO2, and using seals. not matter. Instead
using what instead of matter? Using
balls or ping pong with cans, no? Interact to here. That you are actually in this stage using copper nano and zinc or zinc galvanized, no? For and putting in the middle vessel with CHV. Somebody, how to say, for octane, no? This you say you have a CH3 in the middle in kit of CH3. Actually, first it's a kit of CO2. Now it's CH3 in CH3. In this way.
I'm not clear on what you mean there. I think we have to go through that again. So what you're saying is CH3 kit. Okay, if you can see it there. CH3 in a CH3 environment.
Yes, and
what do you hope? What would you think that you would get from that then?
Like I don't know, gradient of 2 string spheres, like against some games.
So the gradient would come from just the mass difference between a ratio like of 10 to 1 or something like that of the amount of CH3 on the outside versus the amount on the inside, or maybe the concentration or something to get some kind of gradient there?
In this, no, for obtain CH3 or tritium or deuterium, you have GaNs of CH3 put in the middle of one environment. No, first it's CH carbon, no, CO2. CO2 obtained with copper nano and zinc. I ask, if you use one ball of I don't know copper oxide GaNs in left side, and in right side using zinc oxide, what you obtain, no? One is in matter state, another is in GaN state, and interact together, no?
I'm not sure what you get then. Maybe it's been discussed before. I don't know. I just know that the plates between the zinc and the copper oxide should create a carbon condition, and that carbon condition should pull out the carbon out of the CH3s, leaving the H3 behind. And I'm not sure beyond that what's supposed to happen.
Okay, move on.
Sure, maybe someone else has something they could say about that. I don't know. I don't know. I haven't experimented enough with this to start with, and I don't know enough about it to speak more about that. Okay, well, let's move on then. You guys are commenting what about water and tides? The moon, the water, the tides, the water is pushed in and out of the hole in the world, and anyway, seems like a bit much to get into here. What else? Anybody have something else they'd like to bring up? Now's your big opportunity to show your anti-gravity device to the entire world. Some part of it. No takers?
In 2029, no, I asking Mr. Keshe, what about my kind GANs of rust, and Mr. Keshe explained. I have a discussion in a group with another colleague, and he say, oh, Mr. Keshe is not confirmed what it's about. It's blood or hemoglobin, this type of GANs obtained with raining water and bunch of iron and stuff, copper, brass, and other things. I looking again the video, and I don't know. It's somebody always try to make critics, like sticking the, how to say, you sharing with another. My experience. I make this gun, so interact with another guns in this way, crystallize. It's change color. It's I have one type of guns with CH3 in top. In the middle, it's CO2. And in the bottom, it's, I don't know, couple zinc oxide with nano or copper oxide. In weighing how to change, no? One time it's staying this level. After yesterday, CH3 is settled down versus, I don't know, it's, I share these things, no, my experience, my feeling, and somebody say, oh no, my God, no, it's not possible. This you have a bunch of screw, or I have a purity, I have a zinc with 99%. I have I spend how, I don't know how to say, how money for these things. I say, okay, if you want to watch what share, okay, it's no. If not, say it's my opinion. No critics. No, not try to stop sharing. You know. First, I make this coils like a Sabrina system, and okay, I try with the hands moving. Okay, it's okay. Mr. Keshe say moving with your mind, with your thoughts. Okay, it's possible. I have these things. I share it. Somebody always have to say, oh, Mano, it's not right. It's not good. It's not working. How to stop it with these things? My heart say, continue. Move in this direction. No, when ask you in chat or in group, it's not for only for confirmation, for my existence, my is insecure. It's for understanding. Okay, I monopolize your time.
Thank you. Appreciate your feedback there. It's true. A lot of times we just have to show whatever it is we're doing, and that's often the process that needs to take place for us to get the understanding and move to the next position. And sometimes it just has to be accepted for what it is rather than criticized or, you know, try to improve on it or otherwise tell someone how to do it so-called correctly and so on. Sometimes they just need confirmation that they did something, there was an experiment, you got some sort of result, and you move on to whatever the next great thing is. So we all have our personal experiences with this technology, and it varies all over the map from very, you know, tiny little things that we notice right through to very large things we notice both in our experiments and in ourselves personally as we change and transform through all these different things that we do. So there's definitely some give and take that way, and we have to be compassionate sometimes with people and their experiments. It's easy to put someone or something down for what we see, and we don't think it's enough or it's too obvious or simple or something. Then it may not be the case. There can be a lot of reasoning and process gone on in some of these so-called simple experiments. And we have to just recognize and have respect for that process in the individuals that it occurs in. And yes, as Skywalker mentions, some of us are still waiting for a miracle. But I think it's getting closer and closer every day. There's lots of little small miracles and larger occurring. And we're working our way towards a plasmatic universe, whether we like it or not. We will like it. It's just getting there can be a rough transition, especially for those that are ingrained in the current technologies and believe they need to keep going for the next 100 years, which ain't going to happen. Okay, more comments, questions, etc. What do we have going out there? That would be interesting. Anybody, anything to show and tell or bring up for a topic here? Or are we done for today? I don't have much else that I want to present here, I don't think. Just in mid-project and many things going on. I had my traumatic event last week where my cola bottle that was set up, well, I have to put the cap on before I turn that sideways. My cola bottle I had set up in my lathe behind me here ended up rotating and separating from the lathe part. This came apart, and the cola bottle went flailing away, and this went spinning away without its cola bottle. And that was due to the glue was not set properly at that point. My goop had, it's literally called goop, had come unglued. Let it set for almost 2 days, but that wasn't enough in this case for that particular substance. It needs a couple more days of cross-linking. So with this particular bottle, I've gone with epoxy, which is a much better alternative in this case. It sticks really well to the bottle, and there's a cup in there where the whole thing's filled in. Where this sits inside there, it's very solid as a way of mounting the screw threaded part onto the bottle itself, so that now I can mount the bottle in various places, and it'll be centered and able to rotate without a bearing on this end and so on. So it's a viable rotating reactor, and pretty happy with that. And I'll also be working with these kinds of plastic bottles there. You can actually dent them, push them in. They're considered to be, well, they call them unbreakable. So you can bounce them off your desk and you're not worried about the glass breaking in some of these kind of things. They're made for setting up little scenes inside of, you get them with some instructions that comes with it, how to, you could have different things that you put inside, some kind of artwork or whatever, and you can put liquids inside and have that snow material, so you turn it upside down, it looks like it's snowing inside, that kind of thing. So they're waterproof and very nice packages. Should probably give some indication where they come from. Let me see if they say on this. So I get them through the Michael's craft store. There's available in other craft stores as well. Well, it doesn't have any hint of a no hint of a company on that one. They're made in China, so I guess that's expected. But oh, here's a hint on here on the sticker. It's just a company called distributed by MS. It looks like MSPCI in Irving, Texas, made in China. Celebrate It is the trademark, so it's probably attainable through Celebrate It. It's a plastic water globe, 486805. That's probably about the best information I can give you on that. Plastic water globe is the name of it. And I do recommend them because they are pretty cool. They're very durable. Comes with a sealed kind of thing that goes in first, and you can mount other stuff on that platform, such as I've done with this one, which is I've mounted another ball on that little platform, as you can see here. And these other little balls, which I've explained before, are these, which are found at the dollar stores for making round ice balls for your drinks. A round drink, basically. You can pop this top, pour your water in there, put that back on, and put it into the freezer and freeze it. Once it's frozen, you can separate it through this little thing here, open it up, and get your ice ball out. But still, it makes a great little GANS container. It's got a hole in the top. It's closable. And bingo, if you glue it onto another substrate here, onto this thing, then that's openable, and you can take out your GANS eyeball reactor out of the middle, or whatever you happen to have in there. And the whole thing goes into the mechanism like that, and then it has a nice screw, heavy-duty screw cap that goes over the whole works and holds it all together and seals it as well. So you have a totally sealed but accessible unit that you can take apart, interplay with the different parts. And what I'm going to do with it, if I can find that little Septa Seal that I had earlier. I think it might be my last one too. And I really need it. And what is here on that bottle cap? Now it seems to have jumped ship and wandered off somewhere here. But suffice to say, I will find it. And the idea is to glue on the little Septa Seal onto the center of this rotatable sphere here. And once the Septa Seal's in there, then I can take well, there it is. Once I've got that little green Septa Seal thing on the top there glued on, then I can use this or some other syringe, preferably one with a little finer needle, but this works too, and push it through the Septa Seal into the center of the sphere. And if that little hole was open there, or a Septa Seal in it in that other reactor, in this little one here, for example, it'd be very easy to put another Septa Seal on the top there.
Rick,
so
you don't see Rick, you don't see it in, I don't see in the screen large. You have only a window. You have a whiteboard.
Oh, okay, just let me
to see what okay.
yeah, right. I need to spotlight the video, I think is probably what's happening. Let's see, what do we do then? Oh, okay. Yes, let's see what was happening. It had to share up there. I didn't realize it was still sharing because the window was blocked by my other
Okay, it's okay.
window. Sorry about that. Thank you for letting me know. Okay, there it is. So I guess you can see the video okay there. Well, anyway, suffice to say that if you couldn't see it before, you could on live stream, but not in the Zoom apparently. But this was the sphere I was speaking about. The Septa Seal would go on the top here. And I've got a needle that would be able to penetrate the Septa Seal, go inside the sphere, kind of like that in perspective. And if the little, if this little cork was off the inside, then I'd be able to put the needle all the way into this sphere as well if I wanted to remove or replace or extract or do anything that I wish to with the needle, with gases or ganses or any other materials that I wish to put in or extract from these devices. If you were making materials, for example, and creating fields, but maybe the materials were being created in your second sphere in the middle there, well, then you could insert this through the first septa, through the second septa, withdraw the creative materials that you had in there and pull them out through the whole rotating mechanism, let it continue rotating and doing its creation thing inside without disturbing the magnetico-gravitational arrangement of the fields as they are. So the idea is to get in, get out without disturbing things too much. And to be able to do that while it's still in that rotative, compressive, turbulent, plasmatic condition that's called upon in the Keshe patent application in order to create the fields that are necessary. So it's one of many ongoing projects here and just requires a bit more time and attention and some money to be put into it to carry on with it. As many of us, that combination of time, money, energy, and attention all at once is pretty hard to come by in our modern world. Okay, I think that's all about that for now. I hope to have more positive results in terms of getting some actual experiments up and running here. Hopefully by next week, instead of talking about it, we'll start to be able to actually see some things going on and the placement of materials and interactions of fields to get some results. Time to show some results. Lots of talk, we need some action here. So that's what's going to get focused on the next couple of weeks, to try to come up with some, let's see some scintillation, let's see some light, let's see some shimmering, let's see some interaction of fields in other ways. Can we feel the fields? Can we see the fields, or the results of the interaction of the fields? Can we smell them? Can we feel them? Can we feel a temperature difference? Can we see some sort of visual difference? All these things need to be confirmed. Okay, should I wrap up for today? Anybody else have anything they want to bring up, talk about? I don't really want to talk about the tides and stuff here. If you guys want to sort that out, you can, but all right, well, let's call it a wrap for today then. See, what else can I say? Stay tuned for the Keshe Knowledge Seekers Workshop coming up on Thursday at 9 a.m. Central European Time, which is midnight on Wednesday for people on the west coast of North America. And what else is coming up here? Well, there's various other things if you're part of the private teachings of the Keshe Foundation, which is you can sign up for on the Keshe Foundation website, or the various other places, the kfssi.org or the keshefoundation.org sites have the ability to sign up as a KFSSI student, Keshe Foundation Spaceship Institute student. And for 100 euros a year, you can become a student and attend the classes with some teachers that are approved by the Keshe Foundation, as well as various recordings that have gone on the last 3 years now. Especially the ones going back to 2015, which Mr. Keshe delivered initially to start off the private teachings, which they still use now as an essential part of the core of the private teachings and discussing those various teachings that came out. So it's pretty important information. I think there's even some missing videos, some missing files that came up recently that are being reviewed now with, again, some critical information for those that need it, for that are working on their reactors or on their understanding of the knowledge of the plasma technology. And There's also work on the KF Wikipedia that's been ongoing and is progressing nicely with translations into many languages now as well. So that's at what kfwiki.org, I believe it is. And you can find that by also searching in Google now, as you can find much of the information of the Keshe Foundation that's been spread by Mr. Keshe and all of the knowledge seekers through Google. Google highlights the, what do you call it, records the words from the knowledge seekers workshops that have been transcribed and other workshops. So now those words become searchable, and that brings up the various workshops when you search for keywords such as Keshe and plasma, for example, or Keshe and soul of the man, or some sort of some of the sayings of Mr. Keshe will actually come up with the workshops that they come out of. And there's actually ways of searching those workshops to find the keywords as well through the search function in Google, as well as other types of media, Facebook and so on now as well. So it's becoming easier and easier to search for information and get the knowledge that you need to. Basically, all you really need is what gets you to the next position, what gets you to the next point where you can progress. So you can get a vantage point, so you can see where to go to the next step. So maybe some critical piece of information to complete an experiment, maybe something you need to know to be able to have a better perspective on the way the universe works, that kind of thing. Anyway, enough talk for now. Get back into work, you guys, and let's see some creative reactors and other devices that we can use to interact with this world of the physicality that we find ourselves in here on good old planet Earth. We might as well have fun while we're here. So, as Mr. Keshe says, before he starts up his reactors that we were talking about earlier, his gravitational effect reactors and for creating energy and so on, and he would do a little prayer to his reactors before he started them multiple times each day and say, I hope you're going to have as much fun with this as I'm going to. So I think that's a good way to pray to our reactors. Let's have a happy, positive intention going into it, and perhaps you'll find the results that you need. Okay, let's call the day, night, or morning, depending where you happen to be for now. And we'll see you back here next week at the same time and place for yet another Keshe Plasma Reactor Group with myself, Rick Crammond. Okay, I'm going to start the shutdown process here. Like shutting down a nuclear reactor with all these different links and whatnot. Uh-oh, I'm having trouble with the Livestream producer shutdown. We are processing. Can't touch any other buttons on my control panel here till we've processed it out. Just about there, I think. I think it didn't crash and we're okay to live another day. Okay, I'll end the meeting. Bye.